Alright, today's the day that it all comes together. Okay? All the possible rational roots, the sign rule, Descartes' rule signs, upper and lower bounds, all that synthetic division, the factoring, the quadratic formula, all comes together. Okay? We're going to start with a function, not that one, there's more to it. 6x to the third plus 35x squared. Yep. Let me make sure it is over. Yes.
Yeah, recording.
35x squared minus 52x minus 21. Alright, that's our function. And we want to find all the zeros. We will find all of the roots. Now remember, we have all of the numbers of all of infinity, right? But we can get it cut down, so how do we go from all of the numbers in all of infinity down to just like 20 or 10 or just a few? What do we do? Okay, but what do I pick to test from?
First.
P's over Q's. Yeah, the first number and the last number. Okay. So these are the P's and these are the Q's. So all the factors of P. What are all the factors of 21?
1, 3, 7, and 2.
Yes. And the factors of Q?
1, 2, 3, 6.
Okay. Right. Let's get those written down. And then we need P over Q. Those are our possible rational roots. P over Q. By the way, how many zeros does this, how many solutions does this problem have? 3. Okay, so, and it has, if I use Descartes' rule of signs, it has one sign change, so that it has at least one positive root. If you put a negative through, that will tell you how many negative roots it has. Here's a little shortcut, okay? When you're testing for negative roots, just change the sign of the numbers with odd powers, because those are the signs that are going to change. And then look at that problem, and that problem will tell you how many negative roots it has. So, like, this one has a negative, this one has an odd, so it's going to change signs. That one won't change signs. That one will change signs. That will not change signs. So there are 2 sign changes. So it has 2 or no negative roots. By the way, we're not going, let me say this one more time. I've said this before, but I can't remember because everyone's doing this at a different time. I can't remember if I said it to this class. We're not going with sign changes from here to here. It's not from the original to the new. It's sign changes throughout the problem after you've run a negative through there. Okay? So this is a negative and it changes to positive, that's a sign change. Positive, 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 negative, that's a sign change. So that's 2 sign changes in the problem. Okay? Alright, so that's going to help us maybe pick some of these roots. Now, the P over Q. There's only about 200 of them. So all of these over 1 will be exactly the same thing. And then we have to put all of them over 2. Then we have to put all of them over 3. Now 3/3 is already up there because 3/3 is 1. But 7/3 is not up there. 21/3 is, because that is 21 over 3 is 7. We already have that. And then all of them over 6. 1 6, 3 6 is up there, 7 6 is not. 21 over 6 is 7 over 2, and it's up there. So we got it. Which is good, because I'm out of room. So that's good that we've got them all. So we just went from infinity to 24, so that's kind of good. For 3 that work. 3 out of 24, that's anyway, let's not focus on that. Let's not focus on that. Okay, now we start testing. We pick numbers, and we put them in. We can test for upper and lower bounds if you want, okay? And with this many numbers, it's probably not a bad idea, but sometimes I like to just use my testing of zeros to also be my upper and lower bounds testing. Like I'll start with 1, and if 1 works, great, I found a 0. If it doesn't work, then I check the signs. Okay, did I get sign changes? No, well then, not only is it an upper bound, it doesn't work, but that means I've got a fraction that does work. So, I like to do those 2 steps in one to save a little bit of time. Okay, so let's just go ahead and start by testing 1. If I put 1 into this problem, 6, 35, negative 52, negative 21. What's going to happen if this works? What does working look like? Then a 0, okay. So bring down to 6. 1 times 6 is 6. 35 plus 6 is 41. 41. Negative 52 plus 41. Well, it's not an upper bound, and it's not a 0. Right? It's not an upper bound, and it's not a 0. Okay, let's try 2. Six, 12, 2 times 47, 4. Alright, 2 times, or negative 52 plus 94 is, 2 times 42 is 84. Alright, it doesn't work, but what does it tell me? It's an upper bound, okay? There is not a number bigger than 2 that works. So do you know what this means? It's a fraction. 1 didn't work, 2 doesn't work, and nothing bigger than 2 works. So our 1 positive root is a fraction. Okay, but here's the thing. There's no need to test positive 7. There's no need to test positive 21. 7 over 2 is out. 21 over 2 is out. 7 over 3 is out. So we have eliminated some. We're down some of them now because we have found an upper bound. How do I know this is an upper bound? Remind me of that. No sign change. No sign change. Okay? All of these are positive. No sign change. So let's see. We've marked out the positive 7 is out. Positive 21 is out. Positive 3 is out. Positive 7 over 2, 21 over 2, 7/3. Those are out. Okay? Do you want to go after this fraction, or do you want to start looking at negative numbers? Negative numbers? Okay. Alright, what do you want to start with? Negative 1? Somebody said negative 1, someone said negative 3. Negative 1? 35 minus 6 is what, 29? So it's a negative 29. It's not negative 1. And not only is it not negative 1, because I don't have like every other sign here, that's not even going to be a lower bound. So I haven't found a lower bound yet either. Remember, on negatives, for a lower bound, it's every other positive, negative, positive, negative, or negative, positive, negative, positive, negative, positive. If you're looking for a lower bound, change the sign every other sign. Somebody want to try negative 3? I forgot her. 17, negative 51. Yeah, no. Definitely not. What's our next negative? Try negative 7. Try negative 7. See what you get. It is 0. Bring down your 6. That's a negative 42. That's a negative 7. Positive 49. Negative 3. Positive 21. 0. Okay, so we found a 0. That's great. A 0 has been found. Okay, this is a cubic. What's this? It's a quadratic. It's squared, right? This can be factored. If it can't be factored, it can go a quadratic formula. So we don't have to keep doing this anymore. We are going to do one problem where you do have to keep doing it, but this is not it. So now, this is going to turn into 6x squared minus 7x minus 3. Okay? So I'm looking at a negative 18 and a negative 7, negative 9, and positive 2. Alright, so 6x squared plus 2x minus 9x minus 3. I can take out a 2x. Then I have 3x plus 1. Take out a negative 3. 3x plus 1. What does x equal in this one? 3 over 2. There's that positive root that we just knew had to be a fraction. What does x equal in this one? Negative 1/2. Alright. We said at the beginning we're going to have 3 answers. 1, 2, 3. We said at the beginning we're going to have 1 positive root and 2 negative roots. We've done that. everyone have this written down? Okay, we're going to do another one, but you're going to do more of this one than I am. Okay? Okay, once you get this written down, let's talk about it for just a minute. Before we write down anything, let's look at this problem. How many roots does this have? Four. Four roots, right? How do you know it has four roots? X to the fourth, that's the highest degree. How many positive roots does it have? How do you know? There are no sign changes. No sign changes in this problem, so it has zero real roots. So when you're listing your p's over your q's, since it's obvious it doesn't have any positive roots, do I need to worry about this plus or minus business? Because they're all going to be what? They're all going to be minus. They're all going to be negative. Because there are no sign changes. There are no positive real roots. Positive rational roots. Let me say that. Positive rational roots. Okay. Get your p's over q's listed. I'll give you a second to get your p's over q's. All right. So what are your p's over q's? Great. Okay. Now I'm going to let you in on a little secret. Okay. When that number is not 1, you will most likely have a fraction for one of your roots. Because something in front had to multiply to get that to be not 1. It's not always. Sometimes just to kind of like change up the problem or trick you or what, I don't know why, but sometimes you can factor that number out, so it's not really a number. It's just a multiply. Well, we're probably going to have one of these fractions, but we can find the fraction last if you want to. Okay? Alright, so what do you want to start with? -1. Okay. 3. So I'm going to bring the 3 straight down. It's 20. Alright. -1 works. Woohoo. Now let me ask you this. Is this ready to be factored? Why not? It's not a quadratic. It's just a cubic. So I have to do this again. And you're going to use a lot of paper. I don't even bother rewriting it. I just put the line right there and do it again. If you want to rewrite it, go right ahead. But remember, plant a tree. Okay? So what number do you want to try now? -2? Okay. 3. -6. 2. And then what? And then 8 and negative 16 and then 3 Okay, and then what does this become?
Quadratic.
Now it's a quadratic. I can factor that. Actually, you can factor that. Alright, so what two numbers multiply to equal 24 and add to equal 14? 12 and 2. What is this? What factors out of this? 3x, and I'm left with x plus 4. What factors out here? I'm left with x plus 4. So I have 3x plus 2 and x plus 4. What does x equal here? And what does x equal here? Exactly. So how many, what are my 4 answers? If I have 4 answers,
Negative 4, negative 2/3, 1, and negative 2.
alright, very good. We said we were going to have 4 answers. We said they were all going to be negative. Here they are. Boom. Right there. Okay? This is not a difficult process. It is a time-consuming process, but it is not difficult. Don't confuse difficult with time-consuming. Who confuses difficult with time-consuming? Lazy people. Lazy people confuse difficult with time-consuming. It's not the same thing.